Good morning, everybody. Today, we're back into it. We're continuing on our networking adventure. And today, what is a router and what does it mean to route? Well, the short version is a router allows communication between different networks. Stick around and we'll find out some more. Do 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 diddly do 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 diddly do 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 diddly do 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 do. So far, we've talked a bunch about the idea of broadcast domains, and a classic old school once upon a time switch was just one broadcast domain. The VLANs split it up into, or allowed you to split it up into multiple broadcast domains. But what if you've got those different broadcast domains and the computers on them, but you actually want them to talk to each other? You're going to need something to act as a router. Okay, let's jump into it. Tiny Brian! Let's get to diagramming. So we're just talking about this idea of having, come on back, I'm going to go super old school, just some switch. Switch 1. And some other switch. Yeah, I probably could have marked that as switch 2 after I copied it. That's fine, switch 2. Okay. And between them, we're going to have something acting as a router. So the short, fast way to draw a router in your diagram is a circle with like an X through it. It looks kind of like a railroad crossing sign, at least, here where I'm from. And switch would be a rectangle, usually with arrows pointing opposite directions, but hey, the word switch written big will do just fine. And let's just cable those up. Doop. And let's get some hosts in here. Yes, 1980s looking computers I've longed. Well, not to actually have one, I'll be honest, but so cute. Yeah, right, there we go. And what we've got going here is 2 switches, or for our purposes, broadcast domains. And they are connected up to some hosts, one in each set behind their switch, and a router between them. So a router, we said briefly, allows communication between networks. Now we're going to get way more into the idea of what a network is, well, at least subnetting and everything when we get to that. But let's talk a little bit about it right now. A network is a series of IP addresses, contiguous IP addresses, all lined up in a row that can talk to each other without going through a router. And all of those hosts inside of it are going to have some IP address within that range. Okay, and so all the computers over here on the left hooked up to switch 1 and up to whatever this port is on that router. Let's say that they are all, pick color might be easy on your eyes, that they are all in the network of 10.0.10.0/24. What? Well, again, we'll get more and more into this when we get into subnetting, but the short version of it is 10.0.10.0/24 would be the network address, the first address within that range of contiguous, all lined up in a row with no gaps, addresses. The /24 is a way of writing out a network mask. It could also be written out as 255.255.250.0. 255.255.255.0 is the same thing as /24. But, /24 is a lot easier to write, so we're just going to stick with that for the moment. And that network mask, though, basically just says how much of the address has to be the same for everyone in the network. That /24 or 3 255s and a 0 means the first 3 octets all have to be the same. Okay, and so all the hosts over here on the switch 1 side are going to start with 10.0.10 dot something. 10.0.10.100. Yeah, too big, 100. Maybe for this first computer over here, /24. And I'm going to go ahead and put in as well something called a gateway. And the gateway is going to be the IP address of your router on your network. So here I'm going to go ahead and say, IO, that's hilarious, 10.0.10.1. Come on over to the other computer over here and say that it's got an address of 10.0.10.101 and still a gateway of 10.0.10.1. Excellent. Now, that 10.0.10.1 that's the gateway, that's going to be the IP address, literally, of the router we set on the network. And so that means that if this thing up the top here is our router, let's label that. Let's call it router 1. Or, you know, for short, I'm going to just say R1. Well, we're literally going to put that IP address 10.0.10.1 on that port. And on most router or layer 3 switch, we'll talk about that in another one, in most operating systems like that, the command would be something very much like config t interface ETH or gig or something, whatever it calls it out on that switch, and then the port number. Here I'm just going to say 0. And then IP address 10.0.10.1. And maybe you got to type out the 255.255.255.0. Maybe you get away with your /24. I'm just going to say /24 here for space reasons. And let's just make the color match. Awesome. And so that's literally what I would type in on R1 for that port if that was Ethernet 0. Ta-da! Is that port number. I'm just going to say 0, save some space. Then that I would have just put that IP address on that port. Now, I might have needed to do a no shutdown. That might have made some sense. Yeah. Okay, and so now that IP is on that port. If I was trying to put another IP on another port, well, sure, yeah, right? Let's say that everybody over here on the left on the switch 1 on that side was in this 10.0/24 network. Well, maybe over on the right, everybody over there, pick a different color. Hey, y'all, let me know in the comments if red and purple aren't working for your eyes. But over here, I'm going to say everybody is in the network. 10.0.20.0/24. It could have certainly been like 10.0.0.0, 10.0.11. I'm just putting a little space between them. All right, and so then everybody over on this side is gonna have some address that looks quite a bit like that. So maybe my computers down here are 10.0.20.100/24 with a gateway of 10.0.20.1. Turn it up a little. Beep, beep. And 101. Yeah. And so then on that same router, presumably, if that other port over here is, say, port number 1. Oh, well, in my command line back on that switch, I would have said, so I can line this up. Oh, come on, friend. I can line this up. I would have said exit, probably, to get out of that port, and then interface, ETH1, or whatever that port number is called, and then IP address. I'm just switching to this red here just so it stands out. 10.0.20.1 /24 or dotted decimal 255, 255, 255, 0. And then press enter. Come on, friend. And again, you know, probably maybe a no shut down there, but I'm just going to ignore it for now. You're back. Cool. And now I would have had an IP address on that port as well. Right, so my diagram, I'm going to go ahead and just grab this, copy paste. And now we could say that on this, port number 1, there is the IP address 10.0.21. And on the port 0, there's 10.0.10.1. And now, well, cool. Now router 1 has access to both of these networks. And all of these clients over here on the left have access to their default gateway of 10.0.10.1, and all the ones over here on my right have access to 10.0.21. And when they want to talk to each other, well, they can send traffic to their respective default gateway to talk. Huzzah! We're getting better and better. But let's go nail it down some more. Can I move this whole thing down? Yes, I can. Okay, because we talked earlier with the idea about how switches have a MAC address table. Well, routers potentially would have a MAC address table as well for the whole MAC learning thing, but the main table that you'd be thinking about when you're thinking about a router is going to be, conveniently, the routing table. Yeah, it's not exactly complicated there. And from the command line, you would type in show IP route, press enter, and it would almost certainly anyway, different operating systems might do it differently, but almost always show IP route, and that's going to print out its current routing table, or IPv4 routing table anyway. And in there, this would be different from that MAC address table where it was back there, it was MAC, port, and VLAN. Here, I would expect something very, very, very much like for show IP route. I would expect to see a network listed off, and also something like interface. Oops, no caps. Interface / next hop, something like that. And then down to the end, something that says AD/metric. Not sure we'll have time to talk about that one today. We'll play it by ear. I'm trying to keep these a little bit shorter. And so with that in our table, or something very, very, very much like that, well, if I had not put any IP addresses on this router, gone, then I would expect nothing to be in my show IP route, nothing to be in my routing table. Some routers would present an empty table, some would just like not show anything, like you didn't type a command at all, just nothing. But yeah, if you don't put any IP addresses on there, if you don't do set up any routing at all, it'll just be blank. But if you just typed these commands in along with no shutdown, and you plug some cable into them, because it's got to be not just an IP on the interface, but also a working interface. So a cable plugged into it, something at the other end, so it's up. Well, I would expect in this case that we would see these two networks listed off, that we would have an entry in here for the 10.0.10.0/24 network in our show IP route, and that it would be listed off here as our interface / next hop. I would expect something very much like, I'll do my blue here, our Ethernet 0 as our port. And then AD and metric, again, not sure we're going to get fully into it on this one, but I'll go ahead and tell you, I would expect it in this case to be 0/0, almost certainly. Okay, and then, I think you see where we're going here. I'm going to, pause for a second if you need to, but what would you expect to see for that Ethernet 1? Yeah, you're going to see not our 10.0.21 necessarily, though some routers would show that as well, subtly different. But I would expect to see, generally speaking, the network address listed in there. Our 10.0.20, not the 10.0.21 probably. And we'd see that it's our Ethernet 1 for the interface. And the metric, again, I would expect, without going into much detail here, that it would be 0/0, almost certainly. And one last thing, I would also expect to see a little C next to both of those. I'll do a lowercase, to say that these are connected routes. What does that mean? The quick version is, it means that there are routes that got there because they're on some interface of this router. They're the most trustworthy type of routes. What? We'll get into more details on that another one. But putting an IP on an interface on a router is going, and having that interface work, is going to mean that the network associated with that interface is going to be in the routing table for that router. And now, well, I mean, kind of obviously here, but now that router has access to both of those networks. And so now when traffic shows up, some ping or another, right, shows up as traffic coming up the wire and hits the port on that router, if it's destined it's coming up from the computer over here, it's coming up from the computer over here, 10.0.10.100. And it's destined to 10.0.20.100, and it comes up on that switch, and then the switch sends it up the wire to the router, and the router gets it and sees, oh, the destination is 10.0.20.100. Well, it's going to check its routing table if that's the destination address. The router will. And it'll say, do I know that network? Is that here? And it'll check against the first network. Oh, 10.0.20.100, is that in 10.0.10? 10.0/24 network. Nah, it doesn't fit inside there. The beginning of the address doesn't match up well enough based on the network, the network mask. And then, okay, how about my 10.0/2000? Does it match up against this 10.0/20.0/24 network? Well, that 24 just means the first 3 octets, 24 bits, have to match up. First octet, second octet, third octet, yep. And so it would know, this is the interface I need to send it out. And send the traffic out that interface. Yeah, now I only have 2 networks here, so it's not like there's much of a choice, but routers can certainly have many more than just 2 networks that they're aware of. And so knowing which interface, which network to send it to, it's going to be matching based on best match for its routing table. Yes. Okay. Let's get some more detail in this, because I've been ignoring MAC addresses, but MAC addresses didn't go away. So, like I said, throw some MAC addresses in here. What's color I haven't used yet? Try not to use red and green at the same time. Don't want to hit a bunch of y'all's eyes, so I'll do light brown. Okay, so let's say that computer at the bottom left here is MAC address A. And then we got a MAC address B over here. All right, so 10.0.10.100 is MAC A. 10.0.10.101 is MAC B. Let's jump way over and say that 10.0.20.100 is MAC Y. Come on down, friend. And that 10.0.20.101 is MAC Z. Y and Z are definitely not hexadecimal values. Whatever, that's fine. They should also be a lot more than 1 character in the MAC, so let's just run with it. All right, and so now, if your computer over here, 10.0.10.100, is trying to send out a ping, woo, right, ICP echo request or whatever, and that's the payload that's being sent out, and it's being sent from your computer, 10.0.10.100, over to someone over here. Who's that? It's that person over there that's watching. It's their computer. 10.0.20.100. So that's our destination. So IP source. Come on, hands. Source is, we just said 10.0.10.100, and destination is 10.0.20.100. Sorry, I know this is all red. Doesn't exactly fit from a moment ago, but it's gonna do. All right, so there's our IP part of things. Like we said, there is still Ethernet. So this message being sent out of your computer is still coming from your NIC, your Ethernet NIC or Wi-Fi, but it's got MAC addresses too. And so it's going to be able to send this out from your MAC at Ethernet layer, your MAC, which is apparently MAC address A, but it's going to have some destination as well. Now, if you happen to be here for the ARP video, I gave you this ahead of time, so anybody who was there for that, good on you. You already know what's up. For everybody else, now we got to think about who can your computer send this to their MAC address, because, well, we can't send it to MAC address Y. Why? Well, again, from that ARP thing, ARP being the mapping of MAC to IPv4, you send out a broadcast message, who has whatever this address is, send it back to me. But, well, my switch is my broadcast domain. And you don't send broadcasts past your network. There's kind of sort of exceptions and corner cases, but generally speaking, broadcasts are contained within your network, also within your broadcast domain, though it's not exactly the same thing. And so I can't ARP for 10.0.20.100, but hey, that's a good thing, right? Like imagine if everybody was trying to ping a 1.1.1.1 Cloudflare's DNS, if everyone had to broadcast to everyone else in the world, that's not going to work. Okay, and so we need someone to send this to, someone whose MAC address is on our broadcast domain in our network to send this to. Well, conveniently, for just a second ago, we just said we got to send it to our default gateway, to our router. And so what we want to do is we want to send it, yes, from your IP address 10.0.10.100 to theirs 10.0.20.100, from your MAC to the MAC of your default gateway. And so, yeah, your router is going to have a default gateway as well. And I'm going to just say it's an L for the moment. Why? Just because it's convenient. We're going to say everybody over, pardon me, that Ethernet 0 has a MAC address of L because it's on the left side. And Ethernet port 1 on there has a MAC address of R because it's on the right side. Sure, why not? All right, so these are going to be our 2 pretend MACs for those interfaces, and they will have MAC addresses. Okay, in this case, like we said, it's going to be now in this Ethernet message. And let's encapsulate the whole thing here. So your ping is getting sent from your IP to the destination IP on the other network, from your MAC to the MAC of your default gateway. And so that was built inside your computer. Shrink it down so we can wave it around a little better, and that comes up the wire and it hits the switch. Well, the switch has got ports of its own, and that whole MAC address table thing has still got to work. And let's say that you're on port 1, there's port 2, and this is like port number 24 over there going to the router. Sure, why not? Well, the switch, when it received this message, if it didn't know it before, it would say, hey, I just learned that MAC A is on port 1 because your source MAC is A. And it came in on its port 1. Sweet. And it's going to say MAC L. Do I know where that is? If not, it floods it, sends it everywhere but the port it came in on, including port 24. It almost certainly already knew. In fact, the ARP thing would have happened, and when it responded, my MAC address is L, you'd have, the switch would have learned at that point. Because your computer is going to ARP for its default gateway as soon as it gets one. Okay. And so presumably the switch is going to know or very quickly learn that MAC address L is on port 24. And so the switch doesn't have to pay attention to the IP stuff. It can just say, oh, look, A wants to talk to L. Send it out port 24. Goes up the wire, and it is received on that port 0 of router 1. And that router looks in there at the MAC table, or pardon me, and it's the MAC address in the header, and it says, oh, destination is L. That's me, says the router. I love mail. Let me look inside. And so it does. It looks inside. Oh, 10.0.20.100. That's not me. That's not any of my addresses. Well, let me just check my routing table. 10.0.20.100. 10.0.10.0/24. Nope. 10.0.20.0/24. Yes. 10.0.20.100 is inside the 10.0.20.0/24 network. And so it knows right where to send it. It sends it out ETH0. Great. Well, what does that mean? Well, you know, it's going to send it over there, out its ETH1. I think I said out ETH0 a second ago. Sorry, it's going to send it out its ETH1 over to that 10.0.20 network. But, well, when it does that, it is actually going to destroy and recreate the Ethernet header. Now, I'm talking about Ethernet here, though you could certainly route between Ethernet and non-Ethernet networks as well, and you destroy and recreate the header. In fact, very likely at just about, oh, wow, I was going to say everybody, but a lot of the people's houses, you've got some little gadget like this that your internet service provider gave you that's got maybe like a coax connection on it for a cable modem, and then an Ethernet port. And by default, very, very, very often, this is a router. Routing between, in this case, a DOCSIS network and an Ethernet network. And it's getting an IP address from the default, from your internet service provider. And it's not just converting between the media types, but also routing between the little network they've given you and the larger internet service provider network. And it's going to, be swapping out that layer 1, the media type, right? But also the layer 2, because DOCSIS doesn't use MAC addresses. But that's okay, because every time you route, you destroy and recreate the layer 2 header. Now, back in our example here, it's all Ethernet. So it doesn't really matter as much that it's, we're not doing the media conversion or anything like that, but still routing always destroys and recreates the Ethernet header, the layer 2 header. And so when it does that, well, we're going to need a new set of addresses for this new network because A and L aren't going to do us any good over here. So, like we said, destroys and recreates. And when it's doing that, well, it's going to send it to the MAC address, in this case of 10.0.20.100. And it's going to send it from its own MAC address. And so if it didn't already know it, it's going to ARP who has 10.0.20.100 and get the response back, and then be able to, when it's building out its new MAC address table, to say, it'll say it's now from MAC R over to MAC address Y here. Completely not hexadecimal, whatever. And that is the message that gets sent out on the wire over here. And the switch is going to say, oh, look, I'm looking for a MAC address Y as my destination. Do I know where that is? Oh, I never labeled these. Let's say it's port number 1 over here. I'll put that one too. Put this one on port 24 as well. Doesn't have to be, but whatever. And so, yeah, the switch can just ignore the whole Ethernet thing, or pardon me, the whole IP address thing, but deliver some message to MAC address Y out its port 1, and now that computer gets it over here. Right? That other person's computer got it. And then when your computer goes to respond, it's not technically going to send it back to ARC because it came from R. It's a subtle but important distinction. It's going to say in its own computer, when it responds with its own ping, the ping application or whatever, it's going to say, well, hey, I'm 10.0.20.100, and I'm trying to respond back to 10.0.10.100. And, wrap up its ping and have its IP headers. And then when it gets around to building out its Ethernet header before it sends it out on the wire, it's going to say, well, I'm going to send this from my Mac to the Mac of my default gateway. Why? Because it's going to look at this and say, well, I'm 10.0.20.100, and I'm trying to talk to 10.0.10.100. And it'll look at its own /24 there. 10.0.20.100/24 and say, okay, if I'm trying to talk to anybody inside my network, based on my network mask, then I will ARP for their IP, get their MAC address back, and then send it directly to them. If I'm trying to talk to someone outside my network, in this case, the third octet 20 and 10 don't match up, and the /24 says they should, well, that means I should send it to my default gateway instead. And so their computer, will have already ARPed for the default gateway, and no, in this case, I'm going to send it, they're going to send it from Y, purple. Come on, fingers, there we go, back to R, I guess, in this imagining. Yeah, but they're going to look that up based on their network. Okay, and then that message comes up, hits the wire to switch 2, right? If for some reason switch 2 didn't know it, it just learned Mac Y is on port 1, but probably it already knew it. And it says Mac R is who I'm looking for my destination. It would have learned when the message came in. If for some reason it didn't know, it would broadcast to everyone but the port it came in on. But nah, it should certainly know. And then send it out port 24, right? And then that hits port number 1 on that router. And the router, same as before, receives this message, says, oh, destination is R, I'm R, I love mail, right? It looks inside, says, oh, but it's not to my IP address, 10.0.10.100. Let's see, do I know where that is? Let me check. 10.0.10, yeah, 10.0.10.100. 10.0.10.100 fits in this 10.0.10.0/24, because the first 24 bits, or 3 octets, match up. I guess I'll send it out my Ethernet 0. And so it's going to do that. And so it says, well, I'll send it from my MAC address on Ethernet 0. When it's building out that MAC header, the new layer 2 header. And so, yeah, now it's going to be from MAC address L to MAC address A. If it didn't already know, the router would ARP for it. And then this would be the message that gets sent out of its port 0 over here. Hits port number 24 of switch 1. It checks the MAC table on that switch. Oh, destination A. Yep, I know where that is, port 1. And we've routed the traffic. Ta-da! Okay, and here's the deal. Yep, this is what routing is. Routing allows communication between these different networks, these different sets of IP addresses that are all in a row, and that how big it is, where it starts and stops, is defined by that network mask. And so everybody on one of these routed interfaces of the router, everyone connected out of port 0, is going to be in the same network as each other. Needs to be if they're going to be able to talk to each other directly. And they're going to be in the same network as the IP address on their default gateway. Again, because you need to be able to talk to them on your same network, right? If you're in a different network, you got to go through a router. And so your router's got to be in the same network as you. Otherwise, how are you going to ask to get there? Yeah. And another network, a different network over there on the right. Everybody on switch 2. Awesome. Okay, let's just check the time. How we doing? Ooh, running a little long. Here's what I think we're going to do. Next video, I'm going to get into configuring this on an old Cisco virtual router, and we will set up these routed interfaces and route between a couple of VMs and take a look at that, and then use Wireshark to take a look at it as well to be able to watch those MAC addresses change. All right, everybody. This, again, still is a blast. I'm having a great time. Do me a favor, if you can, if there's something you want to know about, if you got some feedback for me, I'd love to hear about it. Drop it in the comments. And otherwise, hit that like button. And if you do like what you're seeing, you want more, click the subscribe. I'm Brian Forget. We'll see you next time. Please make a left at the next router.
How sure are we that this is the right path? I mean, we haven't even talked about OSPF or BGP or nothing yet.